Introduction: the world of deepfakes. Imagine a world where videos and images can trick you into believing something that never happened. That's the power of deepfakes synthetic media created by artificial intelligence to mimic real people, voices, or events with astonishing realism. The term deepfake comes from blending deep learning, a type of AI that processes information in layers, with fake, because, well, it's not real. Deepfakes can be fun, like creating playful videos, but they also pose serious risks. From spreading false information to invading personal privacy, they can harm individuals, stir up social conflicts, or even threaten national security. Criminals might use deepfakes to create misleading content like fake speeches or inappropriate videos to deceive or blackmail others. That's why detecting deepfakes is so crucial, and it's a fascinating challenge. In this short audio guide, we'll explore how cutting-edge algorithms spot deepfakes by uncovering tiny clues that reveal their artificial nature. Let's dive into the world of deepfake detection. How deepfakes are made. Deepfakes rely on two AI algorithms working together. One creates a convincing fake image or video, while the other acts like a detective checking if it's real. The creator algorithm tweaks the fake based on feedback from the detector, refining it until it's nearly indistinguishable from reality. It's like a game of cat and mouse, but the stakes are high. How we detect deepfakes. Detecting deepfakes is like solving a puzzle. Algorithms look for tiny flaws that give away the fake. Here are the main ways they do it. 1. Spotting facial flaws. Algorithms like convolutional neural networks, think of them as super smart image analyzers, examine faces for oddities like unnatural blending around eyes or mouths, weird lighting, or unrealistic skin textures. For example, a model called ExceptionNet can spot these flaws by studying pixel patterns. It's great for catching obvious fakes but struggles with super realistic ones. 2. Tracking eye blinks asterisk. Ever notice how people blink naturally? Deepfakes often get this wrong with too few or irregular blinks. Algorithms analyze blinking patterns using tools like long, short-term memory networks. While effective for older deepfakes, newer ones are getting better at mimicking blinks, so this method has its limits. 3. Checking facial movements asterisk. By tracking key points on a face, like the nose or eyes, algorithms can spot unnatural movements like distorted face swaps. This works well for detecting swapped faces but is less effective for completely synthetic ones. 4. Looking at video flow. Videos should flow smoothly, but deepfakes sometimes have jittery movements or mismatched lip syncing. Algorithms like 3D CNNs check for these inconsistencies across video frames. They're great for catching dynamic flaws but need multiple frames to work. 5. Listening to lip syncing asterisk. When lips don't match the audio, it's a big red flag. Tools like SyncNet compare audio and lip movements to spot mismatches. This is super effective for videos with sound but useless for silent ones. 6. Analyzing hidden patterns asterisk. Deepfakes leave subtle traces in their data patterns. Algorithms like RaiseNet dig into these patterns to find clues like artifacts from the AI that made the fake. This method is robust but can be tricked by clever attacks that hide these traces. 7. Peeking into frequencies. Deepfakes often mess up the invisible frequency patterns in images or videos. By analyzing these with tools like Fourier transforms, algorithms can spot fakes. This works well for subtle flaws but struggles with compressed videos like those on social media. 8. Feeling the pulse asterisk. Here's a cool one. Real people have heartbeats that slightly change skin color as blood flows. Deepfakes often miss this. Algorithms can detect these tiny changes to spot fakes, but they need clear, high-quality video to work. 9. Catching microexpressions asterisk. Humans show fleeting emotions on their faces, but deepfakes struggle to mimic these microexpressions. Algorithms with attention mechanisms can spot these gaps, though they need high-quality footage. 10. Adapting to new fakes asterisk. Since deepfake tech evolves fast, algorithms use tricks like few-shot learning to adapt quickly with just a few examples. This helps them stay ahead of new fake-making methods. A new breakthrough: heartbeat detection. Intel recently developed an exciting new method that detects deepfakes by analyzing biological signals, like changes in blood flow that reveal a heartbeat. Unlike older methods that focus on visual flaws, this approach looks for signs of life that deepfakes can't replicate. In tests against datasets like Face Forensics++ and CelebDF, it outperformed traditional methods, making it a game changer for spotting high-quality fakes. The challenge is ahead. Detecting deepfakes isn't easy. Newer fakes are so good that they fool many algorithms, especially if they're made with advanced AI like Style GAN3. Social media compression can hide fake clues, and sneaky attacks can trick detectors by tweaking data patterns. Plus, many detection methods are too slow for real-time use. It's a constant race to keep up with deepfake creators. The epic battle continues asterisk. Picture deepfake detection as an epic saga, with algorithms as heroes fighting to protect truth in a world of digital deception. From spotting tiny facial flaws to listening for heartbeats, these tools work together to unmask fakes. As deepfake technology grows craftier, our detection methods must evolve, blending visual, audio, and even biological clues to stay one step ahead. Thanks for joining me on this journey into deepfake detection. Stay curious and let's keep fighting for a world where truth shines through.